In question number 1, letter D, we're going to put all of these pieces together into equations. And we're going to use the equations to help us really understand what the best option really would be if we were investing our money in these cases. So for each of these options, we need to remember that we just found a percent multiplier. And anytime we're dealing with percents, we're going to deal with the geometric type of problems. Geometric problems were again covered in the previous chapter. In the previous chapter, we spent a lot of time talking about the geometric structure of an equation. So I'm just going to fold up a bit of my paper here just to make a quick note to myself that I can refer to. And if you don't have your previous packet to refer to yourself, this might be a good thing to copy down quickly so you have it for reference. The geometric equations, which is for anything that has a multiplier, is going to be the following structure. We usually called it T of n equals. I'm going to switch to y equals now, and I'll explain why eventually, but for now you don't need to worry about that. What we need to think about is this. We always start with the initial value times, and we usually use parentheses for times, the multiplier to the power of n. And I'm going to use x in this case instead of n. But it doesn't matter what letter you choose. X is going to be more customary in this chapter, and again I'll explain why once it becomes more important. But I just want to make sure it's clear the x or the n is an exponent, a power lifted up like that. So option 1 was the, I'm going to zoom out so I can see it here. Option 1 was the initial value of $1,000 with the multiplier that went once a year. So that was the one that I calculated in the first part of part C. The multiplier was 1.12 because that was the percentage once a year, the annual percentage. So if I take that exact structure and simply plug in these numbers, I'll get y equals initial, which is 1,000, times multiplier, which is 1.12, to the power of x. And I'll just highlight this so I can remember. Notice I'm color coding everything that went together. When I did it once a year, that was my multiplier, so that was my equation. I can do the same thing for all the other ones. So let's notice where we got this info and let's make sure we can see it. The second option was twice annually. Twice annually was the one that we did in part 2. So again, I'll color code it so I can keep it clear for myself. That means that I'd have y equals, option 2 was another initial value of 1,000 times its multiplier we figured out was 1.06 to the power of x. Now, you'll probably notice if you check the answer key that x looked a little bit different on the key, and I'll explain that in just a moment. But for now, let's just kind of keep our momentum going here, and I'll address that difference in case you noticed it. The third option was the quarterly option, and again, we looked at quarterly. Quarterly was the one that was 4 times a year. We already looked at what happened, how to get that multiplier, so I'll just look back at option 3 to check. Y equals 1,000 initially. Its multiplier was 1.03 to the power of x. And then, keep my color coding consistent here, finally option 4. Option 4 was the one that was compounded monthly. Monthly was the one that we did in part 4 here. So keeping it all straight, I have y equals, its initial value is still 1,000 times monthly multiplier was 1.01 to the power of x. So take a second, make sure that you understand where the equations came from, and then in the next video we'll try to talk about what to do with these equations so you can figure out what this means in terms of real numbers.